This is Pure 2, Chapter 9, 9.3, which we are looking into chain rule, the first real brother, sister of differentiation. Chain rule, product rule, and quotient rule. We'll be looking at chain rule today. First of all, let's do a quick recap on what we've done in Chapter 9.1, 9.2. In 9.1, what we've learned is we've learned about differentiating sin x is cos x, differentiating cos x is negative sin x, differentiating negative sin x is negative cos x, and differentiating negative cos x is sin x. So we've seen this clock before, sin cos and a negative sin negative cos. Clockwise direction is integration. Okay, and also what we've also learned is when we differentiate, where was it? Sin kx equals k cos kx, and differentiating cos kx is negative k sin kx. Right. Then 9.2, what 9.2, we've learned more differentiating results, which we call derivatives. We've learned more derivatives, which are here, the exponential and logarithms. Yep. So we've learned about differentiating e to the power of kx will give us k e to the power of kx. Differentiating ln x or ln kx is they're both 1 over x. Now I mentioned why they're the same. We're using chain rule, but we'll see it today. Okay. We'll also learn one exponential function where y equals a to the power of x, then the dy by dx equals a to the power of x ln a. Right, then we're going to incorporate these. These are fundamental results, derivatives that you have to remember. What we're learning today is not a derivative. What we're learning today is skill. Okay, is a algebra skill to differentiate. Right. So, if we have a composite function, okay, composite function means, for example, means a layer of function like an onion. We have 1 plus 3x as the inner layer in the onion. I was going to say, if you have an inner onion and an outer onion, imagine you have to cut it open. You'll be bursting in tears. Anyway, in here, it's just an inner layer, okay, 1 plus 3x, and then the outer layer is just a square root. So we call this a composite function. When we see a composite function to differentiate, we use chain rule. When we see a product of two functions, x times sine 2x, product rule, product. Division, like a fraction, quotient rule. I might be a bit vague in here, y equal ln x over x. Right, so learning chain rule today. So what's chain rule? So chain rule is used to differentiate composite function. Here's a formula, dy by dx equals dy by du times du by dx. So what is this? Well, don't worry. Okay, we'll look into it one by one. So where y is the composite function of x and u is a basic function of x. English department will probably kill me for saying u is a basic function of x, but we are doing maths, you know, who cares about English? So what we're trying to say is if it's like an onion, then u is the inside layer, okay, and y is the outside layer. Right, so we'll use example to show you how do we do this. Okay, example, given that y equals 3x to the power 4 plus x, okay, bracket to the power 5. Find dy by dx using a chain rule. So the inside layer is the 3x to the power 4 plus x, and the outside layer is power 5. So what we have to do is we have to work out. So we have to write out u equal, okay, 3x to the power 4 plus x to the power 5. Oh, no, sorry, not to the power 5. Sorry, not to the power 5. 3x plus 4, 3x to the power 4 plus x, just the inside. Okay. And we're going to write the outside in terms of u. So the outside is y equal, if u equals 3x to the power 4 plus x, then y would now equal to u to the power 5. Okay, because we let u to be inside, so it becomes y equals u to the power 5. Next, we're going to differentiate both sides, okay, at the same time. So on the left-hand side, on the first function, u equals 3x to the power 4 plus x. To differentiate this one, we're going to do du by dx. Okay, not dy by dx, du, because u is on the left-hand side, and we're differentiating with respect to x. So the x is the variable we're differentiating against. So 3x to the power 4 differentiate is 12x to the power 3 plus 1. On the side in here, on the right-hand side, y equals u to the power 5. Now there is no x in here, and should be no x. So we'll do dy by du. So u is your variable in here we're differentiating. So it'll be 5u to the power of 4. The formula tells us chain rule is to work out dy by dx, we do dy by du times du by dx. So chain rule, okay, so chain rule, dy by dx equal, I'm just going to rewrite the formula once. So dy by du is 5u to the power of 4 times du by dx, 12x cubed plus 1. So left hand side is still dy by dx. Now we keep writing left hand side, right hand side. It will come into play later on while we need left hand side. We can't leave it like this because there's a u in there, and it's not like I don't like u. Don't be offended by that. It's not that I don't like u, right? It's just I prefer my x. U so the x, so u, sorry, I lost I think I went off tangent here. U equal 3x to the power 4 plus x, so I'm going to replace that. dy by dx equal 5u, which is x, 3x to the power 4 plus x, bracket 12x cubed plus 1. We'll leave the conversation like this. Okay, we'll leave the conversation like this. Right. So next one. So that's the answer. By the way, that's how we differentiate using chain rule. So practice. Now for this practice, I would like you to do in my order. So just be so follow my order, follow my instruction. Okay. So I don't want you to do the whole thing in a second in one go. So what I want you to do is for each question. Now you might not have enough space for each of them. So use the whole width of paper, and use the whole length of paper. So what I want you to do is I would like you to repeat the step 1 for each question, like what I did for the example. I write down the u function and then the y function in terms of u. So I want you to write down the first step. Okay, the first line. I'll do the first one with you. Okay, the first one, u equals x squared plus 1 and y equals. If you don't want to mess up your notes, okay, feel free to do on a separate paper and then rewrite nicely on the notes. Some people are a little bit OCD like this, and for good reason, because I'm not like that, and I know my notes are quite messy when I write on it. So if you want to be a bit more organized in your notes, you can do a separate paper and come back to this. So that's the first one. Okay, so u is the inside, and then rewrite y in terms of u. I'll do a second one with u as well. So u equals ln x, and y equal to u cubed. So let you have a go. Have a try for the next 3. Okay, so pause the video now. When you're ready for the answer, you can press play. The third one, slightly trickier. The u is actually x squared plus x, and y equals e to the power of u. Fourth one, in here, u equals to 2 to the power of x plus 1, and y equals u squared. For the last one in here, u equals to sine x, and y equals to ln u. Okay. Once you've done this, the next step, I would like you to try to follow the example, find a du by dx, and find a dy by du. Okay, simplify if you want to, if there is a chance. So pause the video now and have a go. Okay, find du by dx and dy by du for each question. When you're ready, press play. Obviously. Right, so in here, du by dx for the first one, du by dx is 2x, dy by du is u squared. Okay. Next one, du by dx, differential ln x is 1 over x, dy by du is 3u squared. Now I'm going to skip the next 3, so I'm going to finish off the question 1 and 2. Now once we've done the next step, have a look at the example again. Once we've found du by dx and dy by du, the next step is the chain rule formula. So dy by dx equal the 2 derivatives multiply together. So in the previous one was 12x cubed plus 1 times 5u to the power 4. So in here, for the first question, you find dy by dx will multiply the 2 derivatives together. So which is 2x times 3u squared. But we remember, I don't like u. So what's u? U is x squared plus 1. So I rewrite that as 6x times u. So 3 times 3, 2 times 3, 6, x u squared, x squared plus 1 squared. And that's the final answer for question 1. Okay. Now, hopefully with that in mind, I would like to have a go at the rest of the question. Question 2, 3, 4, and 5. Have a go at 2 first, sorry. Have a go at 2 first. When you're ready, I'll go through one by one. When you're ready for the answer for question 2, then press play. Right, so question 2, okay. Question 2, I'm going to rub this off just to give me a bit more space. So question 2, to work out the dy by dx, the derivative, so dy by dx equals to 1 over x times 3u squared. So which is 1 over x times 3, what's u? U is ln x, so it'll be ln x squared. Now, one thing to note, ln x squared, okay, ln x as a bracket squared does not equal to ln x squared. Well, why? Because ln x squared could be rewritten as 2 ln x, which is not the same thing. So the square, the whole thing is not the same as just ln of x squared. So in here, you must keep the bracket for the ln x squared. So the final answer will be 3 bracket ln x squared over x. That's the final answer, question 2. Okay. Now have a go, question 3. When you're ready for the answer, you can press play. So question 3, so we know u is x squared plus x and y equals e to the power of u. Du by dx equal 2x plus 1. Now dy by du equals just e to the power of u. Well, why? Well, why is it not, why is it not something a bit more weird? Why is it simple? Well, think about this. If I ask you to do y equals e to the power of x, to differentiate, what will be the derivative? It's just e to the power of x. For example, if I ask you to do, so let's say y equals e to the power of 5x, if we have differentiated that, that will give you 5e to the power of 5x, because the coefficient is 5. The coefficient for the first one is just 1, so 1e to the power of 1x. Now, same thing with this dy by du. U is your x in the right example. U is a variable that we're differentiating with respect to. When we say differentiating with respect to, it means that variable is the thing you are differentiating with. That's a variable. So e to the power of u, differentiate e to the power of u is like differentiate e to the power of x. It's just e to the power of u. Okay. Right. So the final answer, dy by dx equals to, multiply together, 2x plus 1 times e to the power of u, which is 2x plus 1 as a bracket times e to the power of u. U is x squared plus x. That's the answer. Okay. Right, have a go. Question 4. Try to, if you forgot how to differentiate t to the power of x, refer back to chapter 9.2, the standard results of a to the power of x. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, question 4. So we know u is 2 to the power of x plus 1 and y equals u squared. Du by dx. Differentiating a to the power of x is a to the power of x ln a. Now this chapter 9.2. Okay, so chapter 9.2 about differentiating a to the power of x. Differentiating 1 is 0, so it's the derivative is just 2 to the power of x ln 2. Next one, dy by du is 2u. So the final result, dy by dx equals 2, multiply them together. By the way, you must make sure your letters in here are matching. So that has to be du by dx, and that has to be dy by du. So, and this final line in here must be dy by dx. So the letters do matter. You can't mess them up. You can't mess them up because it represents what you are doing. It's like giving a name. It's like calling the person wrong name. Okay. Imagine calling James Mary. You can't do that, right? So, so dy by dx is the name of this final product. So 2 to the power of x of ln 2 times 2u. U is 2 to the power of x plus 1. So it will be 2 to the power of x ln 2 times 2 times 2 to the power of x plus 1. It's quite messy, but in here, we don't have to generally simplify it. We're not, we don't have to. But if you do want to, let's say, if you do want to do some simplifying, what can we do, sir? Well, there's something we can do in here. For example, when you do 2 to the power of x times 2, you can do 2 to the power of x plus 1. Now, this is optional. So 2 to the power of x plus 1, ln 2 times 2 to the power of x plus 1. And that's probably the maximum we can do. Yeah, leave it like this. Question 5. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, last one. So we know u is sine x, u is the inside layer of the onion, and y equals ln u. du by dx, using the sine cos clock, differentiate sine x, you get cos x. dy by du, differentiate ln u is 1 over u. Okay, again, chapter 9.2. So therefore, the result dy by dx equals to cos x times 1 over u. Cos u is 1 over sine x, so cos x times 1 over sine x. That's the same as cos x over sine x. What does that simplify into? Do you remember? Cos over sine, tan, cot x. Cos over sine is cot x. Okay, right. And yeah, okay. So hopefully these examples do show you how we can use chain rule, right? So let u to be let u to be the inside function, and let y in terms of u differentiate on both sides, and then multiply them. Okay, that's the rule, and you have to remember this because we'll be using this very often. Right, next example. Given that y equals 5x squared plus 1, work out dy by dx at the point 49. First, can I ask you to work out dy by dx first using chain rule, see if you're able to try it yourself. If you're unsure, use a pencil. Or if you really do not like to use a pencil in the notes, you can do a separate paper and you can wait for my answer. So what I want you to do first before, again, is using chain rule, what you've learned in previous practice example, and work out dy by dx in here. Okay, pause video, have a go. When you're ready for the answer, you can press play. So we know u is 5x squared plus 1, and y equals root u. I'm going to write root u as u to the power of half. That's a lot easier to differentiate. So du by dx is just 10x. dy by du is a half u to the power of minus a half. So therefore, dy by dx equals 10x times a half u power of minus a half. Okay, I can simplify a little bit. 5x. Now I don't like u because the question is about dy by dx. There should be a u. So in the final answer, I'm going to write u as 5x squared plus 1. So 5x bracket 5x squared plus 1 to the power of negative a half. Then at the point 49, so at 49, dy by dx equals to this dy by dx function has no y, so I just have to replace, has x in there, so I just replace the x equals 4 into the bracket. So 5 times 4 times 5 times 4 squared plus 1 to the power of negative a half. Put that in a calculator. Okay, so put it in a calculator. You should get a very nice 20 over 9 answer. Okay, that's the answer. Right. Next one, example, one more. Find the value of, this is the last one, yeah, last example. Find the value of dy by dx at a point 21 on the curve with equation y cubed plus y equals x. So this time, we have an equation in terms of y. So at this point, okay, so it is impossible to make x a subject. It is impossible to make y a subject. Impossible to make y the subject. So what we're going to do is, okay, so what we're going to do is, instead of trying so hard to make y the subject, we are going to do dx by dy instead. So I'm going to write x equal y cubed plus y. So we need dx over dy. Okay, so dx over dy. So dx over dy. In other words, I'm differentiating x with respect to y. So y is my variable to differentiate. So I differentiate normally, it's just y being my variable. So 3y squared plus 1. If I want to find dy by dx, I flip on both sides. And so I flip on both sides. So I just flip. I flip both sides. Why? Because we need dy by dx. Simple as that. And we need the point 2,1. So at 2,1, then dy by dx equals 2. Now this time the function is given in terms of y. So when we find a value for dy by dx at 2,1, replace the y value instead. So 1 over 3 times 1 squared plus 1. So 3 over, and that should be a quarter. Okay. Right, if you're happy with this, okay, you can have a go at this exam question. That's question 1A, the very, very first question of the C3 paper. Differentiate with respect to x of ln x squared plus 3x plus 5, 2 marks. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, the final answer is just 2x plus 3. So dy by dx equals 2x plus 3 over x squared plus 3x plus 5. If you got it right, well done to you. And then you can go off and do the homework. If you don't, let's go through why. So we know u is the inside layer, x squared plus 3x plus 5, and y equals to ln u. So du by dx equals to differentiate that is 2x plus 3. dy by du differentiate that is 1 over u. Therefore, dy by dx is simply multiply together 2x plus 3 times 1 over u. And u is x squared plus 3x plus 5. So the same as 2x plus 3 times 1 over x squared plus 3x plus 5, which we can then just put it in one big fraction. It's like this. Okay, so 2 marks, easy peasy, lemon squeezy. Right, and that's the end of chapter 9.3.